Okay, so we have independent variables. Let's just pretend, I don't know, this was a dice or a die, or maybe chips in a bag, and you pull one out and it says -1 and 0.3, 3 out of 10 chips. It looks like, let's just pretend there's 10 chips. And 3 of them say -1, and 1 says 0, and 5 say 1, and 2 say 0.1. Or no, sorry, 1 says 2. There we go. And so this is now the odds. So what is the average value that you'll pull out? What's the mean of this? What's the expected value? So for this, you just multiply all these down, and then you add them across, and that's the mean. And then to get the standard deviation, it's just this formula on the formula sheet right here, because these are discrete random variables. Now technically this formula is for standard deviation, but variance is just this formula without the square root sign. So this just means I take every point minus the 0.4, so I have -1 minus 0.4. I square that difference, and I scale it by however rare -1 is. It's 0.3 rare. Then I add it. This is going to be the variance of x. And then I add it to the next one. So 0 minus 0.4 squared times its probability plus ... I'm only going to skip writing 1, but this just implies I'm going to do this with all of them. So I didn't write the 1 and the 0.5. And then that's the variance, and then that equals 1.04, and then the sigma of x is simply the square root of the variance, and so I just type that in and I get this, which is actually not true. I'm supposed to get this 1.0198. I accidentally squared it, not square rooted it. Now I have not yet mentioned, I don't think, that you can do these on the calculator, and what you do is you put in this is L1, and then you put this in as L2, okay, and then you run one variable statistics like normal. So the stat edit, one stat edit, type them in, one variable statistics, and then you do your frequency list is L2. And then it finds it for you. However, it doesn't find variance. It's not the sum of x squared. That's something different. It does find standard deviation, though, and then you could square that to get variance. Okay, that's all I had to do for that one. And then I'm just going to do the same exact thing for y, and I'll just put the answers. So for that one, I just typed it in L1 and L2. Okay, now let w be 3 plus 2x. Find the mean variance standard deviation of w. So this would be like pulling a random chip out of bag X with the -1, 0, 1, and 2, but then doubling that number and adding 3 to it. So that would mean the mean, so the mean of W would be 3 plus 2 the mean of X. Because that's what you do with means, you completely transform them. So 3 plus 2 mu x is simply 3 plus 2 times the, what was the mu of x? 0.4, which is 3.8. Now for spread, you never do the adding or subtracting, you just do the 2. And the 2 actually only goes to this. The sigma of that should just be double the sigma of the old one. So 2.0396. Now I should note Mr. Bishop kind of did everything in his video with variance, but I think long term I'm going to always do everything with standard deviation, and then whenever I need variance I'm just going to square it at the end. And so now the variance would just be this number squared. So 4.16, which you'll note is if I doubled it, then it should be 2 squared times the variance, which is 4 times the variance, which is 4.16. Now my calculator actually said 4.16.000000002 because the number I'm using for standard deviation is rounded. Okay, now using our rules, this one should be easy. So the average of W should just be the average of all the parts of W, added, subtracted, multiplied, whatever. And so I just add the two averages. I get 3, because it's 0.4 and 2.6. And then the standard, I always do standard deviation of the sum is going to be the Pythagorean theorem of all the individual standard deviations. In this case, there's only 2. And so I'll just put the numbers in, and I get 1.371. And then my variance, I'll just square that, which off to the side I can note is the variance of x plus the variance of y. You can just add variances. But we generally don't work with variance. We generally work with standard deviation long term in this class. So I would think Pythagorean theorem, the standard deviations. Okay, and now the difference of x and y. The mean could just subtract the two means. So negative 2.2, unless I did that wrong. But then the standard deviation and variance, this was the thing he said might surprise you in the video, but whenever you're combining two variables, there's more spread always, even if you're subtracting. And so the standard deviation and variance are exactly the same as the previous problem. Now if I'm adding x to itself, then the average should be itself plus itself. And the variance, standard deviation, should be the Pythagorean theorem of all the individual standard deviations. And then the variance is just that number squared. But then for 2x, the mean is the same, but I do it differently. I would say it's double the mean, which is still 0.8. But the variance in this case, standard deviation in this case, I just double the standard deviation, which is kind of surprising, but not really. The idea is the one I'm doing something twice. I'm pulling a number out and I'm pulling a number out. So there should be more variation. But the one, I'm simply taking whatever number and doubling. I'm converting the units or something. And that's going to be even more spread. I just got to convert. Each chip is worth $2 or something. I got to convert chips to dollars, maybe. Okay, and then variance here, just again square that number. Okay, now in x minus x, I'll say right now the variance in standard deviation should be the same as what I just did. Not what I just did in number 6, because I'm still combining the same two distributions, although it's really the same distribution with itself. So I'll just copy those down, and then the mean should be the difference of the two means, so just 0. Okay. And then lastly, and most trickily, if off to the side I said, let's let a equal negative 2x and b equal 5y, then this is simply a plus b. So what is the mu of a? The mu of a would just be negative 2 times the mu of x. So negative 0.8. So the mu of w should be negative 0.8 plus the mu of y is 5 times the mu of y. So I meant the mu of b, which is what? 10 and 3, no, 13. And so plus 13, and so I should get 12.2. But here's the tricky part. The standard deviation of w is not negative 2 standard deviation x. It's the square root of, if I did a and b, it'd be mu a plus mu b. Or I keep saying mu, sigma. And so off to the side over here, sigma of a is simply 2, remember, because standard deviation can't be negative, 2 times sigma x, which is that 1.0 whatever number. And then over here would be sigma b is 5 times sigma y. And so I'm going to adjust those numbers. So I wrote those down, and then I'll stick them into their squareds over here. very sloppy. But then I'll just do. And then the variance is just that squared. So that was definitely a pretty tricky little one, but generally speaking, hopefully this is not too bad now that you've practiced it more.